Just about 30 years ago, we didn't have scientific proof of planets outside our solar system. Today, thanks to advances in technology, we've discovered over 5,300 exoplanets, alien worlds waiting to be explored. Initially, most of these discoveries were large gas giants, but as our capabilities have improved, we've started uncovering smaller Earth-like exoplanets. Scientists have now found over 50 exoplanets with masses similar to Earth and more than 800 with radii less than half of Earth's. We still don't know of many planets in the habitable zone, the region around a star where conditions might support life. But that's starting to change. We're discovering planetary systems with multiple potentially habitable worlds. One such system is Gliese 667, just 23 light-years away in the constellation Scorpius. Gliese 667 is a triple star system, but the most intriguing star is Gliese 667c, an M-type red dwarf. Despite being small, faint, and cold with only 1.4% of the Sun's luminosity, it has a rich planetary system. Initially, scientists thought there were only 3 exoplanets orbiting this star, but after revisiting data, they found 6, at least 4 of which could be potentially habitable super-Earths. What is a super-Earth? It's a planet larger than Earth but smaller than gas giants like Jupiter. Super-Earths can be rocky or a mix of rock and ice, and some may have atmospheres capable of supporting life. The closest planet to Gliese 667c is Gliese 667cb, a scorching world at 200 degrees Celsius, 392 degrees Fahrenheit. With a mass about 5.5 times that of Earth, it has a thick atmosphere and orbits its star in just 7 days, making it unsuitable for life. But the other planets are more intriguing. Gliese 667cc, the second planet, orbits within the star's habitable zone. It has a mass of 3.8 Earth masses and a radius 1.8 times that of Earth. Its year lasts 28 days. With an Earth similarity index of 0.85, it's one of the most Earth-like exoplanets discovered. Because Gliese 667c is a cooler star than the Sun, its habitable zone is closer to the star, about 0.12 AU compared to Earth's 1 AU. This means Gliese 667cc is likely tidally locked, with one side always facing the star. The temperature differences between the two sides could be extreme, but if the planet has a thick atmosphere, it might help moderate these extremes. Gliese 667cc receives 10% less light than Earth, but most of the light is infrared, so it receives a similar amount of energy as Earth, which could support liquid water. If the planet has an Earth-like atmosphere, it could maintain an average temperature around 30 degrees Celsius, 86 degrees Fahrenheit, making it potentially habitable. Living on Gliese 667cc would be unusual. The planet would receive faint red light from its star, while the 2 other stars in the system, Gliese 667a and b, would be visible as bright stars in the daytime and shine like the full moon at night. Our Sun would appear as a distant star. However, the nearby red dwarf is known to emit intense radiation flares, which could pose a challenge for life on the planet. The star's magnetic activity could also reduce its energy output, further complicating conditions for life. Another challenge is the planet's higher gravity. Gliese 667cc has a mass 3.8 times that of Earth, meaning gravity would be up to 60% stronger. A person weighing 75 kilograms, 165 pounds, on Earth would weigh 120 kilograms, 265 pounds, on this planet. This higher gravity could affect the planet's surface and any potential life forms. The planet's higher mass also suggests it could have a thicker atmosphere, which would increase atmospheric pressure. If the atmosphere is similar to Earth's, the pressure would be higher but not extreme. If the planet has a Venus-like atmosphere, the pressure could be hundreds of times greater, making conditions less hospitable. Despite these challenges, life on Gliese 667 cc may still be possible. Life on Earth has adapted to extreme conditions, and life on Gliese 667 cc could evolve to survive fluctuating light, high gravity, and radiation bursts. Two other potentially habitable planets, Gliese 667 CE and Gliese 667 CF, are nearly identical in size and mass. These planets are farther from the star, so they receive less energy, which might make them too cold for life. But, like Gliese 667 cc, they could have thick atmospheres that trap heat and help maintain stable conditions. Finding 3 planets in the habitable zone of the same system is rare, but 4 is almost unheard of. Studies suggest that planets in the Gliese 667c system receive solar radiation ranging from 20 to 200% of what Earth gets from the Sun, making them good candidates for habitability. The habitable zone around Gliese 667c has 2 key boundaries: the inner boundary between 0.095 and 0.126 AU, and the outer boundary between 0.241 and 0.251 AU. Planets within these ranges could potentially sustain liquid water. If a planet is too close to its star, water will vaporize and escape into space, making the planet uninhabitable. Planets too far from the star risk becoming frozen. But with the right atmospheric conditions, they could remain habitable. In 2013, astronomers confirmed at least 6 planets in the Gliese 667c system, with a possible 7th. Planets E and F are confirmed to be within the habitable zone, and while Planet D's orbit is still uncertain, it may also be habitable. This means Gliese 667 cc, CE, CF, and possibly CD are all candidates for life. The discovery of densely packed planetary systems around M-dwarf stars like Gliese 667c suggests many more such systems exist, each with several potentially habitable planets. Since M-dwarfs make up over 70% of stars in our galaxy, the number of habitable systems is likely far greater than we thought. As new telescopes and technologies come online, our ability to discover and study these distant worlds will only increase. Who knows what Earth-like planets we'll find in the coming years? What star system would you like to hear about next? Let us know in the comments, and don't forget to click the super thank you button if you enjoyed the video. Thanks for watching.